Hi. Well, hello.
Hello.
I'm Kevin,
I'm Alex.
and we're going to talk to you about the Axoloti. Yeah. And if you hit spacebar. Yeah. So, the Axoloti is a circuit board with an open source firmware and visual programming language. So it's actually a piece of hardware and a piece of software. It comes from Belgium. It was developed by Johannes Teilman. Also, the axolotl, which is the animal it was inspired by, is from Mexico, in case you wanted to know. But no, the entirety, it's a visual programming software similar to Max. Yes?
Do you know why it's called the Axoloti?
Actually,
I do. So,
go ahead and take
this
that.
is fun, isn't it? Basically, what happened was Johannes, back in like the 90s, he was actually trying to work with these ideas, and he couldn't really come up with anything in the 90s, but he had the idea of like a visual programming language for audio. And back in like 2012 to 2013, there was a program in Belgium called Art and D. Thanks. Try to keep a straight face. It was basically a collaboration between art and research, and in 2013 he made something called the AXO. So the AXO was basically like a prototype of the Axoloti, and it was funded by the government for this program, and he had like a small user base testing it through the program. But by the time that the program was finished, he didn't want to stop working on it, so he set up a crowdfunding thing in December 2014, which almost reached 200% of its funding. And in August of 2015, they started shipping out the Axoloti core, which the community's only been growing since then.
And while there is a growing community, it's not a very big community. It's still a relatively small project, especially considering the team is one man. But he's actually been doing a significantly good job. So, moving into that, some of the strengths of the Axoloti is that it's actually super flexible. It can essentially do anything. You can use the patcher independently to make digital synthesizers and things like that. But it has 700 factory objects and over 2,000 user-created objects, similar to Max in the sense that, the community is growing the potential for the software itself. And it has a variety of things actually put into the board here, if you can see that. So it has a variety of inputs and outputs for MIDI and, quarter inch, as well as my favorite part, which is the micro SD card slot. And I think that, along with the actual microcomputer that is attached to it, is what actually makes this so significant, because the only thing you need from an external source is power. You don't need to keep this connected to a laptop in order for it to function. It can be put into a independent sort of housing that you don't have to plug into anything as long as you have a battery within it.
Another important thing to note is that it has 19 soldering points, so you can basically put anything onto it. Like what we did here is we used photoresistors for it, so we can basically just like wave our hand over it and it makes weird sounds.
But we could put a bunch of photo sensors. We only have 2, but you could have a variety of photo sensors on some sort of matrix and have each one of them affect a different actual object within your patch.
Also, from what I understand, not all the soldering points aren't just inputs. They can act as inputs or outputs. I'm not entirely sure on that one because I didn't test it, but that's what I've heard about it. Also, the source code for the Axoloti and like the firmware, it's all like open source stuff. So if you want to like modify that, you can just do that.
Mm-hmm. And really, that's really what I love about this piece is just the open-endedness of it, just the versatility. It's really like flower. I don't know how else to put that, but it's a fun. Like in the future, when this becomes more popular, I think this will be a fundamental component in a large variety of projects. It'll just become a standard part, I believe. And like you said, it's super customizable with all the different soldering points and things like that. It doesn't come with a case, but going back to the community, there's a bunch of like printables that you can like 3D print. There's also people that are selling some made out of metal or plastic or whatever, and it's super cheap. Okay, like the competitors are the organelle, which costs like $500.
Yeah, this costs usually around $75 to $85.
Yeah, it's like 65 euros.
Yeah.
But no, that's really the beauty of this thing is like it is super cost effective. A piece like this for not even $100 blows my mind. It does have a few weaknesses though. If you want to go ahead and touch on those.
Yeah, if you remember Max, it can be incredibly confusing because it's a lot like Max. It's got a lot of stuff, but sometimes like that can be a bit overwhelming. And like, yeah, there's a deep learning curve, so you can get lost in all the features of it. And also because it's not so well known, there's not a lot of like tutorials and like people talking about it except for on the one forum that's for it. And for some people, it might be like too open-ended, so you might be able to like to do too much with it, and sometimes that turns people away from things.
Mm-hmm. See, like for example, the stuff I like to do is very experimental, so I love the open-endedness of this. But if you kind of know exactly what you are trying to do, you might find it easier to actually do it in Max, just because there's a lot more tutorials and information out there on Max as opposed to this. If you know exactly what you're trying to do, but you don't know how to do it, it can be a challenge to actually find some good resources online, just because it's so small and independent. So what was it actually designed for? It was actually originally designed to be a hardware and visual programming language combined. So essentially Arduino and Max having a baby, like we said earlier. The Axolotl, however, was designed to live underwater, which this thing can't do.
Yeah. We didn't put that to the test, but we're pretty sure.
Yeah, it's not ours. So as far as opportunities and applications for Capstone, would you like to talk about the modular since you tend to have more knowledge of that?
So on the Axoloti board, I wouldn't try to solder anything to an axolotl.
They're too wet.
Yeah. Probably smell weird too.
Yeah.
Anyway. I'm sorry. There's actually a 5-volt and ground place to like solder onto the board. So it can be powered by a modular system. I haven't seen anything directly like videos, but I've heard people talking about it in the forums that they use these within their modular systems. And they can't exactly fit upright, but they can fit like horizontally. So what people were doing was basically using it as anything. They were using it to like send MIDI to it. All the soldering points in the back led to basically anything. People were using it for like guitar pedals and stuff like that. There's a lot of stuff. And the only problem with doing it with a modular system is modular systems use -10 to +10 volts. This only uses 3.3 to 0 volts, which can kill this thing. So it takes some attenuation to use it, but it's possible.
One thing that I really like about this, as far as for our interactive elements, the contact points are actually little rings in the board as opposed to just like contact points. So you can really easily just loop wires into them as a test. Like, okay, that works. Maybe I'm going to rewire this and that. So it's actually pretty easy to use as far as not needing a lot of solder if you have a breadboard. You know what I mean? That really makes it super user-friendly in the early stages. But as far as a capstone project, what I'd really like to see an institution like Stetson do is develop a sort of program where you're maintaining a database of patches and hardware, because a lot of people will build separate hardware that is meant to plug into the axolotl, making your own sort of control matrices and controllers and things like that. I'd really like to see an institution build a database of patches and hardware that students develop, not just independently, but based off of already existing stuff made by alums or past students, so that every year there's a new patch or new object or new piece of hardware developed for the library. Because that's really what needs to happen for this technology, is for it to really grow and have people facilitating environments for that growth. That's what's going to help make this a more household name, if you will. I think it should be a household name because you can just really do anything with it. It's super open-ended. So I would like to just show something that we built really quick. And I'd like for people to actually get out of their chairs and come play with it. Let's make sure the volume is down here. Gotta open up. So this is the patcher. It's very similar to Max. Should I turn this way? No? Okay. Gotcha. So this is the patcher. We have some oscillator and filter stuff going on. I'm gonna go ahead and make it live. We should hear it on the computer. Is the volume up on this? Or it doesn't need to be, right?
Yeah.
Maybe it...
I wouldn't mess with the dials on the screen right now.
Okay.
I think it's just the mixer or something like that.
Yeah.
So if that's making sound, it should be coming out.
Right. It should be making sound. Alex, do you want to take a look at this?
Mm-hmm.
I'm not sure what's not working.
Let's hope this doesn't hurt my ears again.
Does it work?
I'm not hearing anything right now. Okay.
You got it?
Mm-hmm.
Brilliant. Was it just the pitch too low?
Yeah.
Ah, yay!
So these are the photosensors. If you cover them, you'll. Could we?
Yeah, I heard that little.
Yeah, I'd like to make it just a little bit more noticeable.
Yeah.
It should be this one down here, right?
Kind of.
Okay.
Yeah. Kind of took control of this patch. Sorry.
I'd like to get a wave that's a little bit more noticeable.
There we go. Ooh.
Yeah, it's a pretty crude setup.
Wow.
So, if there was a program where we would be building off of, already existing hardware and patches, this would be what Alex and I contributed this year, and then hopefully next year someone can make something a little bit more interesting or start a new, what's the word? Sort of, string of projects to come up, break off of that, potentially. Yeah, because it's based on light. So
from up
if
top?
you like cover it,
Yeah. The whole
This
thing, yeah.
this is the photo
Yeah.
sensor.
yeah.
Okay. Any questions for these guys?
What's the learning curve like in this guy?
I mean, it's pretty
If you're
steep.
familiar with, did you say learning curve? If you're familiar with Max, it's easier.
Yeah.
You know, if you have a sort of comfortability with that sort of visual programming, patching sort of thing, then you should be able to pick up. That's not really. That's what I like about it is, at least for our curriculum here at Stetson, we already kind of work towards stuff that is kind of conducive with this. You just have to be able to have some time to sit down and actually, play with it.
It's got 700 factory
Where does it start?
objects, so
Yeah,
it's a lot to work with.
yeah, it's a pretty big
Right there.
library already.
Analog channel PC1.
But even then, considering what it can do, it's pretty small, pretty young. And it's also completely geared towards audio, so if you want to build an instrument, you don't really need a lot of hardware outside of this. So normally if I were to do something with an Arduino, I would need the Arduino, I would need the computer with the program that the Arduino could read, it would also have to power the Arduino, things like that. But with this, it's just a matter of having it powered and loading up your patcher right there on the SD card and have it work free and independent.
How quickly does it, when you're working with the program and loading it onto the computer, is there like a reload time when you have to
So
make a change?
It's just a matter of turning off live
Mm-hmm.
and then turning it back on.
Oh, okay. So any changes you make in the programming would do that then.
Right.
Okay.
How many things can the Axoloti control at once? Like, say you have a
Like as far as-
synthesizer, then controlled by this, controlled by like a pedal.
Well,
Is that too much?
no. So I mean, really, it's just a matter of what you can connect to it. So you have MIDI in and out. You have XLR in and out. You have USB in, SD card in, and you have all of these different points of contact here. And right here, let's say like your DSP load at like 7%. So as long as that doesn't go to like 100, you should be okay. You know what I mean?
So is it?
And yeah.
Go ahead.
No. Well, I was just gonna say it's just a matter of your patcher being organized enough for you to maintain all of the
Got it.
hardware, but that might be a problem before
Yeah.
overload.
So is there any onboard storage, or do you have to use an SD card for?
What do you mean by onboard storage?
Well, we take chips.
Yeah. So I was thinking, could you just upload to it without an SD card?
I'm not sure. Most of the people, because most of the research for this stuff is like forums and community engagement. Most people just go ahead and use the SD card because that way, and it kind of works as onboard storage. Yeah, you have to buy the SD card, but once it slides in there, that it's independent. Plus, then you can decide, I'm running a really big patch. I need a 64 gigabyte thing as opposed to like 13, whatever. I mean, what is it, like 12? But yeah, this is just one of the things we could have done. We could have set up like 5 or 6 potentiometers and each one of those affecting a different knob. You know what I mean? And I can pull up videos real quick. A lot of times people just build a case around this, stick the SD card with the patcher, and that becomes their pedal. You know what I mean? As well as there's this guy, the title of the video is Axolotl in the Woods or something like that. He essentially built a box with the axolotl in it, with potentiometers and buttons all over it, with speakers coming out of the sides, and a strap so he can wear it around his neck. And in his backpack, he has the battery cell that is powering the axolotl. And this thing just takes USB power, so it really doesn't need that much. So he was just walking around in the woods, like avoiding trees, just playing with his little synthesizer, making spooky noise. But like that's the beautiful thing is you can actually, if you have an idea for an instrument that doesn't exist, this is your opportunity to make it without being super good at computers. You know what I mean? Like you don't have to be like a coder or
Yeah.
an engineer that can like develop a matrix of some sort.
All right.
But yeah, cool. And we do have some resources. If you go to the Axoloti website, it kind of acts as a central hub, not just for the software and hardware, but also for the community. There's like a links for examples, forums, and things like that.
Does it have like help patches like Max does, or is it kind of like?
They sort of do. It's more of just like example patches.
Yeah.
Of like multiple things.
I wouldn't really call it a help patch, but they're like, this works. So try doing some kind
I
of.
did find a website that has all of the objects and what they do. So that helped out a lot.
Yeah. It's more of a library or database, but like it does break down like what it does. And also, if you make an object, so here, in order to make an object, all you have to do is double click. Oh, I lost my cursor. It's pretty sweet. And let's say you want audio out.
Actually, I'll try an audio in.
Huh? Audio in?
Yeah.
Upside down. Audio in. So it gives you like a list of what it thinks you're trying to make, and it'll tell you when you highlight it, like record audio into table starting from position, and then one. So it does give you a little bit of like. Yeah. So my way of doing it is I know what I want. I don't know if it calls it that, but I'm going to type it in anyway. It's kind of close.
Yeah.
And eventually you find the description that sounds like what you're trying to do. Yeah. But but like Alex said, there is a website where it's all broken down for you.
Yeah.
All right, let's give these rounds a round of applause.